So now we have an example in which a stone is thrown downwards from a bridge. If the stone speed initially was 2.0 meters per second and the stone reaches the water below the bridge 2.5 seconds later, the question is, how high is the bridge above the water? We recognize that as the stone is falling down towards the river or the water, this is going to be a free fall motion. We're going to neglect the resistance. And free fall motion was actually a motion with a constant acceleration, with a very specific motion with a constant acceleration where we actually know the acceleration. Since the stone will be falling down and we'll be looking at the vertical motion here, we need to be able to distinguish between up and down. So here I have made a choice to consider everything that is up as positive and to consider the negative direction to be down. With that, I'm ready to actually translate my problem in mathematical symbols. I'm going to go through the problem and see what I have. The first thing is that I already recognize that the motion is a free fall, so I have an acceleration that has a magnitude equal to g, 9.8 meters per second squared, and I have written it down here as minus g because of my choice. I decided up to be positive and the acceleration always points towards the center of the earth, so in this case will be downwards. So it has nothing to do with the stone being thrown downward. It could be going up or down. The acceleration due to the earth is always downwards towards the center of the earth. Next, I see that the speed initially was 2.0 meters per second. And not only that, but the rock was thrown downwards. So that initial velocity has to be written as negative 2.0 meters per second. Please take a note that this is one of the very common mistakes that I have seen in this type of problems, students forgetting the minus. If you miss the minus here in the initial velocity, that you will be solving a problem for which the stone is actually thrown upward and you will get a totally different answer. Next, the time that is given is 2.5 seconds, and the question here is, what is the displacement? Presumably, if you know the displacement of the stone, that will give us information about how high the bridge was above the water. So I have the problem translated mathematical symbols. Let's look at the equations 1, 2, and 3 and see which one will give us possibly the solution. It looks like equation 2 can give us immediately the solution. We don't have to do anything else. If we plug everything that is given, I have x equal to the initial position x naught plus the initial velocity, which is minus 2.0 meters per second, times t, which is 2.5 seconds. Then I'm going to have minus 1/2 g. I have replaced the acceleration with the known minus g, or minus 9.8. And then times the time squared, which is 2.5 seconds squared. If I move the initial position x naught to the left, I see that the displacement x minus x naught is going to be minus 35.625 meters. So obviously the bridge cannot be the height of the bridge cannot be a negative height. So let's pause here just to sort out what the minus means and how do we report the final answer in this problem. The minus here is because the final position of the stone is at a lower vertical location than where it started. And so we see that if we look at the stone, we started here with x naught, somewhere high above the river, and then we end up with somewhere very low at the level of the water. And of course, x minus x naught should be a negative, should have a negative value. That makes sense to us. But we also see that the height of the bridge will be simply the difference between the position from where we started x naught and where we ended x. So we can see that the height of the bridge actually is going to be the opposite of the displacement. In this case will be 35.625 meters. And this being the final answer, you can actually round to the standard 3 digits that many textbooks and physics professors like to use. So if you want to get an answer down to 3 digits only, you can just report your answers as the height of the bridge to be 35.6 meters.